Right, our first do now problem asks us to determine which expressions is or are equivalent to 6x plus 9. So this suggests to us that there might be more than one answer. So we should go through and sort this out. So this looks like all of these attempted to factor the answer here. So there's actually two ways we can do this. One, we can factor this ourselves, so we can be thinking about this as 3 times 2 times x plus 3 times 3. So the common factor that I can pull out here would be a 3. And that would leave me with 3 times 2x plus 3. And that definitely gives us answer choice C. However, if we really want to go through and test all of the other answers, we can actually go through and do the distribution for each of these. So 3 times x would be 3x, and 3 times 3 would be 9, 3x plus 9. So that's going to give us 3x plus 9, so that's not going to be right. Here we distribute, this is going to give me 3 times 3x is going to be equal to 9x, and 3 times 2 is going to be 6. So not quite the same. Now this one down here, in order to do the distribution, we're going to have to change this to an addition. So I added the opposite there. Now I can distribute in. That's going to give me negative 3 times negative 2. So that's a negative times a negative is a positive 6x, plus a negative times a negative is a positive 9. And sure enough, we see that this actually also gives us the same answer. So we have two correct answers on this problem. All right, let's flip on over and write down our aim for today. All right, today's aim, Kipsters will be able to factor and distribute binomial expressions. So binomial, bi meaning two, nomial meaning numbers or parts. We're going to be looking at expressions that have two terms. All right, so looking at the distributive property, this is something that you've learned last year, and we discussed yesterday. We discussed more about factoring yesterday, but distributive property says that we can multiply each term within parentheses to find an equivalent expression. Let's see an example below. So first, I want to use this one just to prove again. We saw a little bit of this work yesterday. We did it with tape diagrams. I want to do it now again with kind of the more algebraic method. So those of us who think more algebraically can think through it that way. But also to hammer home one last point. All right, so this is 3 times x plus 3. So that's telling us this is 3 groups of x plus 3. So this is going to be x plus 3 plus x plus 3 plus x plus 3. So here we've used this idea that this is three groups of x plus 3, and we've just added them out. Now the next thing we can do is we can use the associative property to just kind of wipe out all of the parentheses there. And again, this is kind of one point I want to hammer home before we look at the next problem, and think about this as, if we're using the associative property, the only way we can use the associative property is if everything is addition. So at this point we do have everything is addition. Additionally, the next thing we're going to do is we're going to rearrange all of the terms. So think about which property that is. We're rearranging all of the terms, x plus x plus x plus 3 plus 3 plus 3. I've used the commutative property, which we know also only works for addition and multiplication. So again, this would infer that we would have to have all multiplications. And if we only had multiplications and additions, now we can combine this x plus x plus x, that is 3x plus 3 plus 3 plus 3, which is 9. And so we can see that proves to us it's the same idea. Now we've got three groups of x and three groups of 3, and that's 3 times x and 3 times 3. So again, this proves to us the idea of how the distributive property works, and it hammers home the point that we use commutative property when we use distributive property, so it really only works if there's addition involved. Well, what if there are negatives and subtractions? So coming down here, we have a negative and we have a subtraction. We kind of saw this on the do now as well. What do I need to do with this subtraction if I want to use the distributive property? So you should be thinking in your head that, well, if I want to use distributive property, I need to change that subtraction into an addition. So we're going to rewrite this as an addition, 3x, add the opposite, and now we can distribute in. Now we have a negative that we're distributing in, so we think about this as negative 2 times 3x plus negative 2 times negative 2. So when we're simplifying over here, negative 2 times 3, that's going to be a negative times a positive. It's negative 6x. And negative 2 times negative 2 should be positive 4. So we get negative 6x plus 4. So the only difference with the negatives is, again, we have to pay really close attention to our sign rules when we are multiplying, thinking about negatives times positives, positives times negatives. So two things to think about in this particular problem. Quick reminders: if we're going to use distributive property, we need to change subtractions to addition by changing it to add the opposite. And when we're dealing with negative numbers, which will often result from this, we'll need to make sure that we're doing a really good job of paying attention to our multiplication sign rule. Finally, down here we're talking about factoring. Factoring, remember, is the concept of removing a common factor to multiply to a binomial. And that's the work that we worked on yesterday. So for as an example, one problem that we did factoring might look like the one that we did on our do now, 6x plus 9. We can factor it out. This is the same thing as 3 times 2 times x plus 3 times 3. We have a common factor of 3. We can pull out that 3, and that leaves us to multiply that to 2x plus 3. Okay, so let's look over at these tables over here, and these are just really asking us to jump through the different forms of a factored or distributed form of an equation, or binomial. So looking at this, we have, if we're using distributive property, we know that we can multiply outside times the inside, so our distributive form just shows us what both of those multiplications look like. 9 times 3 plus 9 times 2. And here this makes it, if we were going backwards, easy to see that we have our common factor of 9. That's where the 9 came from, the outside. And so our simplified form, we can go ahead and multiply those pieces out. It's going to be 27 plus 18, which obviously we could take this a step further and we could say that this was equal to 45. Now this next one we have to be a lot more careful with. Before I want to go through and distribute this one, I'm going to go ahead and change this to an add the opposite. If you're more comfortable rewriting it, please go ahead and do that. And I distribute in my negative 7a. So here I end up with negative 7 times a plus negative 7. And after that, adding the opposite. This is negative 7 times negative 5. And that's really important to pay attention to those sign rules. These are the small details that make the difference between a correct answer and an incorrect answer. Negative 7 times a, that's just going to simplify to negative 7a plus negative 7 times negative 5, and that's going to give me 35. So do the next two. Oh, let's not do the next two. Go ahead and do the next one on your own to make sure that you've got going this direction in your brain. I'll give you a couple seconds to do that. You don't need to pause the video. So in your distributed form, you get the 3 times the 2x plus the 3 times the 5, and that's going to give me 6x plus 15. Alright, so this next one is definitely the weird one. It says the opposite of 3x plus 2. Alright, so it's weird to think about this as distributing an opposite. We could think about this as an opposite of 3x plus the opposite of 2. The only way this is going to get a little bit confusing is if you already have a negative number that you're distributing to in the middle. So we always think about this as a negative 1. Finding the opposite is the same thing as multiplying by a negative 1. And that's really just a quick rule that really makes it very easy to remember this, but it is something you kind of just have to memorize and keep in your brain. So looking at this, we're going to change this negative and we're going to distribute it as a multiplication of negative 1. So that's going to give me a negative times a positive, which is negative 3x plus negative 2. So again, when we see that just negative outside, we're going to make it a negative 1 to distribute in. That's going to do the same thing as just telling us, hey, we need the opposite of whatever we already have in there. Alright, so looking at this, we kind of have an in-between form. This is already a factored form. They've shown us kind of what it looks like with the common factor. So our common factor here is 3 and 3. So what goes outside the parentheses is the 3. What goes on inside is what's left over, t plus 5. Now if we go ahead and multiply this through to get the simplified form, it's 3 times t is 3t plus 3 times 5 is 15. Because of our work that we did yesterday, you should be able to do the next 3 on your own. So go ahead and jump through the next 3 on your own. I'll give you a little bit of a head start, so you shouldn't have to pause the video. Alright, you should have this. Again, we keep seeing down the line our common factors here. So we pull those out to the outside of the parentheses and just leave in whatever is left over. So that's how we're using the factoring. I do want to talk a little bit about kind of these two problems right here really quickly and how we might write those answers. So just as we can change this to add the opposite, we can also do the reverse. We can change it back to a subtraction because we know adding a negative is the same thing as a subtraction. So it's possible that someone may want us to write this as a subtraction, so we could actually rewrite these as negative 3x, change that back to a subtraction of 2. Same thing down here, we could change this to negative 5x minus 25. And that's just something to keep in mind as we look through possible answer choices or different ways that we may be asked to write the expression in the end. Alright, this last set is asking us to factor. So when we think about this, this is the same work that we did yesterday. The only difference that we're going to really see here is that when we get down here, we've got some negatives involved, so we definitely need to pay some careful attention to those negatives and how we're going to work with those. So the first two you should be able to do on your own. So jump through to make sure that you have those concepts in your brain from yesterday and do the first two on your own. So the first one, when I look at it, my common factor is 3. So to get the 12, that's 3 times 4. And to get the 15, that's 3 times 15. So I could rewrite this as 3 times, no, it's not 3 times 15, 3 times 5. 3 times, and then what's left over, 4 plus 5. 3 times 4 plus 5. Here, I can see my common factor looks like it's going to be 5. So 5 times x plus 15 is going to be 5 times 3. My common factor comes out to its undistributed form, leaving x plus 3 in the middle. Now the next one's the tricky one. All right, I have a negative 12 and a positive 15. So when I factor a negative 12, I need to make sure that I remember the only way that I'm going to get that to be a negative is if I multiply a negative and a positive. So when I think about this, I think about my common factor here as being a 3. All right, so I have a 3 here that needs to come out. This one's going to be 3 times 5. There's no weirdness about that because it's definitely a positive value. But this one, I need to make sure that this is a negative value. So I need to multiply in a negative number here. So this has to be a negative 4. All right. So notice I don't make the 3 a negative because I want it to be the same as the one over here. So I don't make that a negative because I want to be able to pull out a positive 3. And what that leaves me on the inside is a negative 4x plus 5. So you have to be really careful with those negatives. And this next one, this is really just a stretch. When we think about this, this is 24 times x, that's an x squared, plus 16x, 16 times x. So we've got a couple common factors that we can pull out here. Because I can actually take this 24, I can break this down into 8 times 3, and break this one down into 8 times 2. So I can pull out a common factor of an 8 and an x, an 8 and an x. So I pull out 8x, and what's left over is 3x and 2. So 3x plus 2. That's more of a stretch, just so you have in your brain. When you break things down, if you break them down far enough, sometimes you'll have multiple factors that you can pull out. In this particular case, you're able to pull out an 8 and an x. You also could have broken this down, and if you really were getting really out there, we could have broken this down in 2 times 2 times 2, and we would have been pulling out a 2 times a 2 times a 2, which we would have slapped back into an 8. All right, go ahead and flip on over to your partner practice work. In this particular case, I'm not going to give you any further instructions on this, so you'll want to go ahead and pause the video now and get all that work done, and then just come back through and check. So again, you just have lots of practice here. Nothing really big in terms of instructions here. So go ahead and make sure that you have the video paused so you can get this work done. And then you can come back and check. Okay, so looking at this, here's the first half of our work that we want to check. Really want to focus in on a handful of these that I've put stars next to. So I'm going to talk just a little bit about them. The rest, if you have any questions, feel free to raise your hand. We'll check those out together as the rest of the class works on their partner work time. So looking at this, what we see here, this one just want to focus in on here. Again, we have this subtraction. So before we want to use the distributive property, because remember, distributive property works on the same terms as commutative property. So we have to have addition inside there. So we change this to adding the opposite, becomes plus a negative 4, and then we go ahead and distribute it in. So the result of that is that we end up with this plus negative 12, because 3 times negative 4 gives me negative 12. Coming down, the next ones I want to look at are down here on the bottom. Looking at this one, we're moving backwards here. Again, same idea. In order to do the factoring correctly, we want to go ahead and change this to a subtraction. Change this from a subtraction to an addition. So this is add the opposite. And when we do so, we want to make sure that we're factoring out the same thing. So since I only have positives to factor out here, I'm going to factor out this is the positive 3 and then negative 7 to match it. And that's going to give me 2d plus negative 7. For this one, we can see that there's actually a t factor in both of them. So we can actually factor out 5 times t. So we end up with 5t times 1 plus 2. Coming down along the bottom, this one's important here. We have, again, the subtraction becoming adding the opposite, but we also have a negative distributed into it. So we have a negative times a negative, which gives us a positive 12 over here on this side. And the last and final one, this is the same thing as the 2 above, is the same thing as this one. When we're factoring out, here we have a negative, so that means one of the 2 multiplications needs to be a negative. And because I have a factor of 8 over here, and it's only a positive, so I'm going to put an 8 there to factor it out that way. Moving on over to the other side, just a couple more to talk about here. This one, just want to catch some of you guys. There is no d to factor out over here, so this one has to stay as d squared. We can't factor that out as d times d. The next one, we have a 5n times n. So n times n is just n squared. So we can just rewrite that one that way. And then negative 5n times the 4 gives me negative 20n. Scrolling down and looking at the bottom, there's only one more I wanted to quickly check in about. This one we can see that the common factor, the only common factor is the variable, so we take the t out. We saw plenty of problems like that yesterday. And so we get t times 3 plus 4. All right, go ahead and move on to your independent work. We'll check out your independent work and move on.